Hey guys. So I don't have super long notes for you guys today, which is probably music to your ears, but I do have a couple of things to talk about before I turn you guys loose on your assignment. We talked last time about solving quadratics, and we talked in chapter one about what a graph of a quadratic looks like, and that's a parabola. What I want to do now is talk about the relationship between solving an equation and what the graph of the quadratic looks like. So if you look on the notes here, I've done a lot of the pre-work already. When I do this lesson in class, I have the students kind of perform all this work, but I didn't want to spend a lot of the time because my concern is not in solving these, but kind of the relationship between the solutions and the graphs. So what I'm going to do, you might want to jot these down you might want to pause and jot this stuff down before I keep talking. But I'm going to show you essentially what I've done. So in the directions, it says to graph each of the equations in the calculator and sketch it on the coordinate plane. And I kind of already went ahead and did that already. I entered this equation into my graphing calculator, and I just got a rough idea of where the vertex was, any intercepts there might have been. This one was crossing the y-axis at 9, which makes sense because anytime you graph anything, this constant right here is always going to be your y-intercept. Because think about how we find intercepts. If you want to find y-intercepts, you put 0 in for the x's, and so these terms will always go away, and that's always your y-intercept. And if you look at this next one, the y-intercept would be 25. I didn't want to sketch all the way up to 25, but it'd be crossing up there. This one, the y-intercept's -2, crossing at -2. And that's not a main part of the discussion today, but just something to point out. I like to always point out just little things that help you connect math and graphs and equations. But what I want to talk about today is, so I graphed all three of these, all right? Here's what you might want to do. Maybe pause this and jot down what I have for number one. Go ahead and do that now. And then I'll move these up, and you can kind of keep pausing and jotting the stuff down, and then I can talk about them all. That way you're not worried about writing as I'm talking. So go ahead and do that. Pause this, graph these first two, and then go ahead and sketch this last one here. Okay, so what I want to make note of is really this number under the radical in the quadratic formula. When you do the quadratic formula, you're always going to end up with a number under the square root. So on this first one, I ended up with -27. On the second one, I ended up with 0 under the square root. And on the third one, I ended up with +33 under the square root. That number under the square root, it has a special name. Now I'm going to jot some of this stuff down off to the side. The special name of the number you get under the square root, so not including the square root, but just the number, is called the discriminant. It's called the discriminant. That number is called the discriminant. And it's really just the b squared minus 4ac part of the quadratic formula. It's the number you get when you just perform that part of it. Now, that number is special because it tells you, number one, how many real solutions your equation is going to have. And we'll talk about the second thing here in a second, but here's what I want you to notice. If that discriminant is negative, then that means you're going to get imaginary solutions. Well, one special thing to note is in any equation you've ever solved in your life, when you get an answer, you're finding where that graph crosses the x-axis. And that's one thing I want to point out, is notice on number 2, I got an answer of -5 right here, and there was only one answer. And notice where the graph was hitting the x-axis. It was hitting at -5. Here, there were no real answers, and so notice the parabola never hits the x-axis. And on that third one, I normally don't have you guys go as far as getting the decimals. We would stop right here, but for the purpose of this, look what happens. I get two answers. One is 0.37, and look where it's hitting the x-axis right here, right about just before 0.5, so 0.37, and -5.37, which is right over here, -5, right around -5.5. Again, that was just a rough sketch. So that's number one in the discussion is when you solve an equation, the answers you get are where your graph hits the x-axis. Those are your x-intercepts. Well, what that leads to is what the discriminant tells us. If the number underneath the radical is negative, if the discriminant turns out to be negative, then that means there are no real solutions. That also means the graph will never hit the x-axis. And this whole lesson is just kind of about relationships between equations, solutions, graphs, making those connections. So if you have a negative discriminant, there's no real solutions, and that means it'll never hit the x-axis. In the second one, we ended up with the discriminant of 0, and that could happen. And notice how many solutions there are when your discriminant is 0. We end up with one answer. And look at why. If your discriminant is 0, then you end up adding 0 and subtracting 0, and you get the same thing whether you add 0 or subtract 0. So if your discriminant is 0, then that means there's one real solution, because there's no difference between adding 0 and subtracting 0. And what that means is if there's one real solution, then that means your graph will hit the x-axis one time. And then lastly, if your discriminant is positive, like I have here, positive 33, if your discriminant is positive, we end up with two answers. And you'll always end up with two answers if your discriminant is positive. So there's two real solutions if your discriminant is positive. And then that means it hits the x-axis twice. So that's a big part of the lesson in connecting a graph with the solutions and discriminants. So the discriminant never tells you what the answers are, but that number will tell you how many answers you're going to have and how many times your graph's going to hit the x-axis. That's kind of the big discussion here. We also talked last time about how a quadratic can never have more than two answers. It never will, because a parabola, look at what happens. A parabola can only ever hit the x-axis two times. So that's the most answers you could have. That exponent tells you the maximum number of solutions that your equation could have. Okay? So just a little discussion about making connections there, and I think there's a little bit of that on your assignment. The last thing I want to talk about, you don't have to take any notes on this, but this shows up in your assignment. You guys are going to have some quadratics to solve. And one thing that's going to pop up, I think, in your work, and I talk a little bit about this in class, is this equation here called the position equation. The position equation comes into play in a lot of science classes because it has to do with Earth's gravity and dropping something from a certain height or throwing something up in the air and it coming down. I mean, think about it. If you throw something up in the air, it forms a parabolic curve. It goes up and then comes back down. It forms a parabola. You are not going to have to memorize this equation. Okay, you're not going to have to memorize this equation, so you don't need to jot it down if you don't want to right now. You are going to have to know what all of these variables stand for and kind of how to use the equation on your assignments. That's what I want to talk about a little bit more. Okay, so I just want to show you, this is in your book on page 193. So if you need to use this for your assignment tonight, this is where it is. It's in the section of 2.4. So here's what all the variables stand for and what the equation does for you. What this equation does is if you know how high something was dropped from, or the height at which something was thrown up in the air, and you know the initial velocity at which the thing was thrown or dropped or whatever, then you can use this equation. This equation will tell you how high off the ground something is after the thing has been dropped for so many seconds. So if I say I'm standing at the top of a 800-foot building and I drop a quarter, how high off the ground is that thing after 3.2 seconds? This equation will tell you that. Okay, so I want to point out what all this stuff stands for. So V naught, this is pronounced V naught, is your initial velocity of the thing. That's what this stands for, and the problem will tell you that. It'll give you that number. If it says something was dropped, then that means the initial velocity is 0. Like there was no force applied to the thing. The problem might say, like if you chuck something down, like I just threw that pen down, if I don't just drop it, now the initial velocity is something else, and the problem will tell you that. Okay, so that's what V naught stands for. S naught represents the initial height of the object. Again, the problem will tell that to you. It'll say, the thing was dropped from a height of 500 feet, or a ball was thrown in the air and it was released at a height of 5 feet. So the problem will always tell you V naught and S naught. Okay. T is the amount of time in seconds that the thing has been dropped for. It tells you that right here. T is time in seconds. And then S is the final height at that number of seconds. So that's the difference between S naught and S. S naught is the initial height when the thing was released from your hand. S is the final height after so many seconds, like the height that you want to figure out how high off the ground that thing is. This is the position equation. You will not have to memorize this. If you need to use it on a quiz or test, I'll provide it for you. But you have to know what to plug in. So if you need to use this on your assignment, make sure you're taking note on what goes where. Okay? So that's all I have for you. Like I said, not an extremely long lesson. But go ahead and work on your assignment. And let me know if you have any questions. See ya.